Hello everyone, welcome back to the 2025 AMC 8 problems. This is the final part. We will be covering problems 23 through 25. So let's just get into it. Problem 23. How many 4-digit numbers have all three of the following properties? The tens in one digit are both 9. The number is 1 less than a perfect square. And the number is the product of exactly two prime numbers. So we're given that this number ends in two nines and is equal to x squared minus 1 for some x. And this is, by difference of squares, this is equal to x plus 1 and x minus 1. You've probably seen this before. And most importantly, x squared is going to be sum 0, 0. Because 1 plus 99 makes a multiple of 100, which means x is going to be a multiple of 10, divisible by 10. So we can find some numbers that work. These two numbers are 1 above and 1 less than a multiple of 10. So for example, 31 and 29 work. 41 and 39 do not work because 39 is not a prime number. And we keep testing this. 51 through times 49 does not work because 49 is a multiple of 7. And since this is a 4-digit number, x must be 2 digits. If x was 3 digits, then x would be, this number would be 5 digits or 6 digits. If x is 1 digit, then it simply wouldn't work. It's too small. And we don't have to try 71 times 69 or 101 times 99, because we know these are going to be all multiples of 3. And 51 also does not work, because then 21 times 19 does not work. It's a multiple of 3. And 81 times 79 also does not work. So we only have to look at these numbers. 61 times 59 works, and 91 times 89 does not work, because 91 is a multiple of 7. That's a tricky one that people might miss. So we might think the answer is 2, these 3, but this number is actually 900 minus 1, which is not a 4-digit number. So the answer is just 1. There's only one number here that satisfies it. So the answer is B. Problem 24. In trapezoid ABCD, angles B and C measure 60 degrees and AB equals DC. The side lengths are positive integers and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions? So first of all, these are parallel lines because ABCD is a trapezoid. And this also means that these are 120, but that's not actually important. First, let's just label these two are x, and let's just say this is y. And we want to find the length of BC. And we can do this by extending this length here so that this is 60 and this is 60, making this an equilateral triangle, which means all of these are x. And again, this is going to be parallel to this, which means this side is going to be equal to this side. So this is x, so this is y. So BC is just going to be x plus y, which means the radius is x plus y plus x plus y, which is equal to 3x plus 2y, which we are given is equal to 30. And we want to find all integer pairs positive integer pairs of x and y that satisfy this equation. We might start with if x equals 8, I'll just write it here. If x equals 8, then y must equal 3. Let's just say these are x and y. And we can find more pairs of x and y by subtracting 2 from x and adding 3 to y, because that preserves the sum of 30. So we subtract 2, add 3, subtract 2, add 3, and again subtract 2 and add 3. And we can check that these work. 3 times 2 is 6, plus 2 times 12 is 24, indeed equals 30. If we try to do it again, we get 0 and 15, which does not work because these are not positive integers. Similarly, going up here gives 10 and 0, which also does not work. So there are 4 trapezoids, 1, 2, 3, and 4 that satisfy these conditions. So the answer is E. Problem 25. Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped ring. Each path starts at the bottom of the grid and ends at the top, always moving 1 unit northeast or northwest. She computes the area of the region between each path and the right side of the grid. 2 examples are shown in the figure below. What is the sum of the areas determined by all possible paths? So for a problem like this, it's very important to look at symmetry. And what I notice about each of these paths is that, let's take this one, is that each path has a mirror image. For example, if you flip it or mirror it across this line, then you get this path right here. And not coincidentally, this path, if you determine the area, is exactly 25 minus the area of here, 11, which equals, equals 14. And this means that each path has a mirror image that is exactly 25 minus the current area, which means a path and its mirror image, let's call it path prime, always add to 25. Which means that the average area of all these paths is going to be half that, 12.5. So all we have to do is just find the total number of paths multiplied by 12.5, and we get this. We get the total area. To find the total number of paths, let's break this path up into 2 different steps. A northeast or a northwest path and northeast paths. So there are 5 northeast and 5 northwest paths, and we want to arrange them in some order. Let's call these A and B. So we could have A, B, B, A, B, A, B, B. So this is a valid path that we could take. And this is just the number of ways to pick 5 of these out of a total of 10, that's just 10 choose 5, right? So 10 choose 5 is 10 times 9 times 8, 7 times 6 over 5 factorial is 120. We do some simplification. We get is equal to 9 times 4 times 7. 36 times 7 is 252. we want to multiply this by 12.5, which is equal to 126 times 25, which is equal to 63 times 50. 63 times 0.5 times 100 is equal to this, which means the answer is 3,150. So the answer is B. All right, so that was the end of the AMC 8 2025 problems. Next video, I'll likely cover 2024. So I'll see you next time.